Okay, last is the iteration method. So for the iteration method, we have two methods, Jacobi and also Gauss, Seidel. Okay, right. So for if we want to apply the method of Jacobi and also Gauss Seidel to find the value of x, y, z or to solve the system, so the matrix of A must be as DD. Okay, so what is SDD? So the matrix of A should satisfy this equation. For example, so for the first diagonal matrix A11, the value must be absolute value must be greater than A12 and also plus A13. So let's say this one A is 3 times 3 matrix. Okay, so A is 3 times 3 matrix. So the second diagonal should be greater than A21 plus A23. And the last diagonal must be greater than A31 plus A32. Okay, then if your matrix is strictly diagonal dominant, then you can apply the Jacobi or Gauss Seidel. Okay, right. So the example show that this matrix, let's say matrix A is STD. Okay, so focus at the first A11. So A11 we have 3 that is greater than A12 plus A13. Yes. Okay, so second diagonal A22 -5 is greater than A21 and also A23. So yes. And the last one, A33 is greater than A31 plus with the A32. Also satisfied. Therefore, matrix A is SDD. Okay. Right. So for the first method, if we want to apply the iteration method, is Jacobi method. So for the Jacobi, you have to put your x1, your first equation x1 as the first subject, second equation x2 as the subject, and the last one x3 as the subject. Okay, as the subject. So this one is for the k plus 1, the one that we want to calculate. So the others will be k, 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 k. So this is for the Jacobi with the initial gas. Initial gas will be given, and then we calculate until we get the stopping criteria. Okay. Alright, so this is for the Jacobi, but for the Gauss Seidel, with the same technique, make x1, x2 and also x3 as the subject. So this one k plus 1, k plus 1, k plus 1. But for the x1, since we don't have the value for x2, so this is the k, and also we don't have the value for x3, so this one is k. But for the x2, see we already have the value for x1, so we take the new value of x1, but x3 the previous value k. For the x3, we already have the value of x1 and x2, so we take the new value of x1 and also x2. Okay, so the formula is similar, just for the Jacobi we take the previous value, but for the Gauss Seidel we take the new value. Okay. Right, so let's try for the Jacobi. Show that the following system is SDD, hence solve the following linear system by using the Jacobi method. Right, so first we need to check the SDD. Okay. Right. So find our matrix A. So we have 4, 6, -5, -1. 12. -1, 6, 8, 0. Okay. So this is our matrix, and now we need to check for the SDD. So 4 is greater than -1 plus -1. So yes. And the second diagonal is greater than 6 plus 0. Yes. And the last one, 12, 5 plus 0. Also, yes. Therefore, this matrix A is SDD. Okay. Right. Alright. Okay, now from the first equation, what we have to do is we have to make x as the subject. So we have x equal to -2 plus y plus z over 4. So this is for the x. So xk plus 1, yk, zk. And then from the second equation, so we can get the value of y. So y is equal to 45 minus 6x over 8. So this one is k plus 1, k. And the last one for z equal to 80 plus 5x over 12. So k plus 1 and k. Right? Right? So from the first equation, we make x as the subject. Second equation, y as the subject. And the third equation, z as the subject. Okay, now we have all these equations. So we have this equation. So we have to construct this table. So we need to find the value of x, y, and also z with the tolerance. From the questions, we have the initial gas. Initial gas is equal to 1 to 5, and our stopping criteria must be less than 0.5. So 1 to 5. 1, 2, 5. So don't have the first stopping criteria. So the first k, so our x, so use this formula. We want to find the value of x. So -2 plus 2 plus 5 divided by 4. 1.25. Okay, for y we have to use this formula. So 45 minus with 6, x is 1, and then divided by 8. So the answer is 4.875. And for z, we use this formula. 80 plus 5, x is 1, divided by 12. So the answer is 7.0833. Okay, and then the stopping criteria, we have to use the stopping criteria, the maximum norm. This is the maximum norm, means the maximum error. So 1.25, when you minus with 1, your answer will be 0.25. So here minus, you get 25, and minus 2.0833. So the maximum is 2.875. So the stopping criteria is must be less than 0.5. So no choice, you have to continue. So the second equation, so find x, so negative 2 plus y. So y is 4.875 plus z. Z is 7.0866 divided by 4. So your answer is 2.4896. And for y, 45 minus 6x, x is 1.25 divided by 8, 4.68.6875, and then 80 plus 5, 1.25 divided by 12, 7.1875. Okay, now you minus 2.4896 minus 1.25. So the error is 1.2396. 4.68875 minus 4.875. Absolute value must be positive. So 0.1875 and 7.1875 minus 7.083, 0.1042. So the maximum is 1.2396. So still you cannot stop. So continue for the third iteration. So third iteration, value for x, negative 2 plus y, 4.6875 plus z, 7.1875 divided by 4, 2.8. And then for y, 45 minus 6x, 2.4896, and then divide by 8, 3.75, 78, and for z, 80 plus 5 times with x, 2.48 divided by 12, 7.7040. 7.7040 minus with 7.1875. So the error is okay, so the maximum is 0.9297. So still you cannot stop. So continue the iteration. Number 4, negative 2 plus y plus z, 7.7040 divided by 4, 2.3655, and then for y, 45 minus 6x, 2.4688 divided by 8, 3.7734, and for z, 80 plus 5x, 2.4688 divided by 12, so 7.6953. Okay, so 7.6953 minus 7.7040, I get 0.123. Okay, so 3.7734 minus 3.7478, 0.0156, 2.3655 minus 2.4688, so 0.1033. So the maximum is 0.1033. So already satisfied because our stopping criteria is less than 0.5. So you have to stop, means the value of x, the answer is x equal to 2.3655, 3 points, y equal to 3.7734, and z equal to 7.6953. So this is your answer. Okay. Actually, you can check lah. You can substitute back this x, y, and z into this equation, and if you can get the value of b here, so then the value of x, y, and z is correct, right? Right. So now for the Gauss Seidel. So Gauss Seidel similar like the step in the Jacobi, but for the Gauss Seidel, you need the new value for the new value. It depends on the new value. If you have the new value, then it depends on the new value. Okay. Right. So example, this example, consider the linear system with B is a transpose. State that the convergent criteria A to be used for an iterative method. Right. Alright, okay. Write the constant difference, specify the equation, and based on the formula, then solve the linear system. Alright, okay. So first we need to check the SDD. So we need to check the SDD first. Right, okay. Actually, I can see at the first one also is not satisfied because 2, 6 plus 1. So it's not satisfied. So what you need to do is you need to rearrange. Okay, you need to rearrange so that it satisfies the equation. So I can see this one is maximum. So when you rearrange maximum, 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 so means now we can change to 4, -1, -1, 6 at the second column, so I want to put it at the second row, and 7 maximum at the third column, so I put it as at the third row. Okay, now I want to check my SDD. So 4, then yes. Second, yes, and the last one. Yes. Okay, so this will be our matrix of A. Right. Okay, now we need to find the equation, but now don't forget our B. We change the row, so 9, 3, -6. Just now we have 9, 9, 3, -6. If 6, but because we already rearranged the equations, so our B is 3, 9, -6. Okay. Don't forget, every time you rearrange the matrix, so the matrix B also will be changed. Just follow the one that you make arrangement. Okay. Now we want to find the value of x. So find the value of x. We use the first equation. So x equal to, from the first equation, we have 4x minus y minus z equal to 3. So we want x. So now we have 3 plus y plus z over 4. Okay, so this is the new value, but we don't have the value of y, so k and k. Right, so now from the second equation, we can make the y as the subject, but we have 2x plus 6y plus z equal to 9. So we want to make y as the subject, so y 9 minus 2x minus z over 6. So k plus 1, but we have the value for x just now, so this one will be k plus 1, but z, we don't have the value of z, so k. Okay, and from the third equation, so from the third equation, we have negative x plus y plus 7 z equal to negative 6. So z equal to negative 6 plus x minus y over 7. So k plus 1. So we already have the value for x and y. So x should be take the new value, and also k the new value. Okay, right. Right. So start with 0. So what is our initial guess? Initial guess is equal to 0. Stopping criteria must be 0.005. Okay. So 0, 0, we don't have. Okay, now for the first iteration, so we have 3 over 4, 0.75. For y, 9 over 9 minus with 2x, we have the value of x, the new value of x, so 0.75. So z 0, and then divide by 6, so 1.25. And for z negative 6 plus x, take the new value of x, so 0.75 minus y also on the new value of y, so 1.25 divided by 7. Okay, so the maximum is, should be here, 1.25. Okay, we cannot stop. Right, so continue the second iteration. So for x, so 3 plus y is 1.25 plus z divide by 4, so 0.8 304. And for y, 9 minus 2x, x new value of x, 0.8304 minus z, minus will be plus 0.9286, and then divide by 6, 1.3780, and z negative 6, new value of x, 0.8304 minus 1.3780 over 7, so negative 0.9554. 4. So negative 0.9354. Negative will be positive 0.9286. So here the error is 0.123. 1.3780 minus 1.25. 0.128 and 0.8304 minus 0.75. 0.0804. So the maximum is 0.1280. So still you cannot stop. So continue for the third iteration. So 3 plus y plus z negative 0.9354 divided by 4. 0.8606 and y is 9 minus 2 the new value of x, so 0.86707 minus z 0.9354 divided by 6. 1.3690. Z negative 6. We have new value of x and new value of y by 7. Negative 0.9298. So negative 0.9298 minus with the negative 0.9354. So the error is 0.123. Okay. And then 1.393690 minus 1.3780. So 0.123. And the last one 0.8607 minus 0.8304. 0.0303. So the maximum is 0.0303. So back to the condition. Okay. I think if you want to continue, the calculation will be quite large. So can you change to the stopping criteria until 0.05 only? Okay. So you just need to stop because it's already satisfied the stopping criteria. But if the condition is 0.005, so you cannot stop. You have to continue. But I changed the stopping criteria to the 0.05 only. So our tolerance is 0.0303. Therefore you can stop. Therefore x is equal to 0.867, y equal to 1.3690, and z equal to 298. So this is your answer. Okay. Right. Okay, that's all for this chapter.